How do hidden forces make massive structures stable? Imagine standing beneath a towering skyscraper or crossing a long suspension bridge. You might wonder how these enormous structures stay upright and safe. The secret lies in unseen forces working behind the scenes to keep everything balanced. Engineers carefully design these forces to counteract the weight of the building, the wind pushing against it, and even earthquakes. These forces are not visible but are essential for stability. Every big structure faces the challenge of resisting gravity, which pulls everything downward, and environmental forces like wind and water pressure. To do this, engineers use strong materials like high-strength concrete and steel. For example, the Burj Khalifa uses a bundled tube design, where multiple steel and concrete tubes support each other. This design helps it stand tall at over 828 meters, making it the tallest building in the world. The shape of a building also matters. Arches and triangles are common because they transfer forces efficiently. The Millau Viaduct, a cable-stayed bridge in France, uses tall pylons and cables to support a slender deck. This design reduces wind resistance and evenly spreads weight across the structure. Foundations are another hidden force at work. Deep, wide foundations anchor these giants to the ground. The Three Gorges Dam in China, the largest hydroelectric dam, sits on solid bedrock and uses millions of tons of concrete to hold back the Yangtze River's water. The Burj Khalifa's foundation extends over 50 meters underground, spreading its weight across a large area to prevent sinking. Tall buildings sway in the wind, which might seem dangerous, but engineers install tuned mass dampers, massive weights near the top that move opposite to the sway. These dampers, like the one in Taipei 101, cancel out motion and keep the building steady. Some structures face extreme conditions. The Sichuan-Tibet Railway, for example, crosses high, unstable terrain with many bridges and tunnels. Engineers design oxygen systems for trains to handle the high altitude and build supports that withstand earthquakes and landslides. These projects push engineering limits and requiring precise planning to ensure safety and stability. All these engineering tricks are not just for record-breaking structures. They are used in everyday bridges, dams, and towers to keep people safe. The curved shape of the Hoover Dam directs water pressure into the canyon walls, while the steel cables of the Brooklyn Bridge distribute weight evenly across its towers. When we look at the tallest or longest structures in the world, we see how human ingenuity uses hidden forces to achieve stability. Each new record pushes engineers to develop new ways to manage these forces better. Whether it's the height of the Burj Khalifa or the span of the Millau Viaduct, these feats depend on understanding and controlling forces that are invisible but vital. Every innovation in this field helps build safer, taller, and more impressive structures that can withstand nature's toughest challenges.